All right, let's review what we did during the first unit when we were talking about patterns and functions. So we started with visual patterns, but here I just have some sequences. Remember, sequences just mean a list of numbers that have some sort of pattern. So my pattern in the first one is adding 5 each time. So what was the kind of pattern we called that when it was adding? We said that that was a linear pattern. And so I would start with a next equals now. Next equals now plus 5, starting at, and what did we have to do to get our starting at? We had to go backwards. So thinking back from 4, 4 minus 5 would be -1. And then we learned to go to what's called the explicit form. So that would be y equals, we start at -1, we add 5, x number of times. Or you might have written it as y equals 5x minus 1. Any of those is totally fine. Looking at the next pattern, how do I go between the numbers? 3 to 6 and 6 to 12. So 3 to 6 is times 2, and 6 to 12 is times 2. So next equals now times 2, start at, this is where we had to go back again, so going forward we multiply by 2, so to go back we need to divide by 2, so that would give me 3/2. We just leave it as a fraction. And we get y equals, start at 3/2, pattern is times 2, and we do that x number of times, so the x needs to be in the exponent, which by the way means that this was an exponential function. All right. So now let's get some practice just going between those two types of equations. So if I have next equals now minus 3, start at 8, I would do y equals, start at 8, pattern is minus 3, and I do minus 3 over and over, so that's going to be minus 3x. Next equals now times 2, start at 5. So y equals, start at 5, pattern is times 2, and when I multiply by 2 over and over, that's what an exponent means. Let's try the next one. So this next one is linear. Next equals now. And it might be easier to do your starting at first. When I'm doing a starting at, and we're talking about lines, remember you have your M and your B, and we always begin with B. So that's my starting at, which means the other number is going to be my pattern, so plus 2. Next equals now times 5, start at 4. So that was how we started off the class, like the first week or so. We talked about different types of patterns, and then we got into the details of something called functions. And to describe functions, we first started talking about domain and range. So domain has to do with your possible x values, and range has to do with the possible y values. And don't forget, I came up with this cheesy thing, knob, which was no repeated values. So no repeats, order from least to greatest, and brackets. These are our 3 little notation things that were important when we do domain and range. No repeats, order least to greatest, and brackets. Functions have no repeated x values. So x does not repeat. Y can repeat all at once, but x cannot. And graphs need to pass the vertical line test. So let's do some examples for domain and range and whether it's a function or not. I'm going to do the domain and range part first for this one. So domain in a mapping diagram, which is this kind of egg-looking one, just means writing down your list of numbers, just making sure we follow our rules. So I'm going to do my squiggly brackets. No repeats in order at least to greatest. So -5, -3, 0, and 6. Then my range is -2, 0, 1, 2, 4. And for whether this is a function or not, it is not a function because you have the -3, going to two different values. So -3 going to two different things means no, it's not a function. Going to the next one with the table, I have my domain. So I need in order from least to greatest. So -4, -1, 1, and 4. And then my range is 5 and -5. Whoops, what did I do? Not put them in order. So -5 and 5. And I'm looking and I notice that I have two places where I have the same x values. I have 1, 5, and then 1, -5. So because that 1 is going to two different things, this is also not a function. How about when I have a set of ordered pairs? Domain, they're nice and wrote this in order for the domain. So 1, 2, 5, and 7. And then range, I have 2, 3. I have 3 again, but I don't write it again. And 9. So I look at my little y values here, and I have 1, 2, 5, 7. None of those repeated, so yes, that one is a function. Domain and range. I'm going to do my brackets. So domain, I have 2, 3, 5, 3. So 2, 3. I don't need to repeat the 3. And 5. And then I have 6, 6, -2, 8. So in order, that would be -2, 6, don't repeat it, and 8. And looking at that again, paying attention, I have 2, 3, 5, 3. Look at those 3s. See how I have 3, 6, and 3, 8? That means no, that is not a function because you have the 3 going to two different y values. Another table, so domain would be -5, -3, -1, 0, and 5. Remember least to greatest. Range, I have -2, -1, 3, and 4. Sometimes when we're thinking about ordering things, it's easier to just write them all down without repeating and then go back and see whether you need to change the order of things versus trying to keep it all in your head, but anything that works. So I notice I don't have any sort of different, I don't have any of the same x values, so that means that, yes, this is a function. I don't have any repeated x values to worry about. The last thing we're going to do is look at graphs for when we're talking about functions or not. So functions mean they pass the vertical line test, which means that a vertical line can pass by without hitting two points on the graph at the same time. So this first graph is a function because it passes the vertical line test. The next one, draw a bunch of vertical lines. They're never hitting more than one spot on my graph, so yes. Versus when I go to this one, boom, that vertical line is hitting my curve in two spots, so not a function. And our favorite non-function, which is circle. So circles are important, obviously, but they're not functions. Okay, then we ended the unit with talking about function notation. Function notation is when you have f parentheses a number, or f of x equals a number. So when you see f of a number, it means to plug the number in for x on the right side. Don't forget your parentheses, or PEMDAS. Please excuse my dear Aunt Sally. I don't love PEMDAS, but it's what you've learned, so we'll go with it. So looking at this first problem, I have f of x and f of 3. What has happened between that and the question's asking f of 3? It's replaced x with 3. So guess what we're going to do in our equation? We're going to replace x with 3. So 2 parentheses minus 5, and we're replacing with what's in the parentheses. And now we simplify. Some people are trying to like solve on both sides. This is basically like my question. Okay? There's nothing, I'm not going to operate over there. It's the question it's asking. I'm going to simplify on the right. So 2 times 3 is 6, minus 5 equals 1. So 1 would be my answer. So the difference of the next one is that I don't have something in the parentheses. So what I'm going to do is just rewrite my function over the question they're asking. Okay, because now what do you notice when I put the function next to the question that they're asking? I notice that the left sides of these equations are the same, or equal. So if the left sides of the equation are equal, then that means that the right sides of the equations are equal. So 2x minus 5 equals 3. And then we add 3 to both add 5 to both sides. And we get x equals 4. Notice, what did I get the first time? I got 1. So you get totally different answers 99% of the time, and when you don't, it's because of a funky situation. You get different answers depending on which way you do it. One, you're substituting in that value on the right. The other, you're setting the two values equal. So you have to pay attention to which situation it is in the problem. Okay, so let's try that in the next one. So g of negative 2. So I notice that that's replacing the x with negative 2. So that means on the right side, I'm going to copy down the equation with parentheses. And now I'm going to go back and replace everything with negative 2. All right. And whenever you see squared especially is where you want to be really careful about PEMDAS. So I need to do my exponent first. A lot of you are wanting to multiply negative 3 times negative 2, but we have to do negative 2 squared. And what is negative 2 squared? Positive 4. Okay, and now we can do our multiplication. So negative 3 times 4 is negative 12. Negative 4 times negative 2 is positive 8. And that will simplify to negative 4. I'm going to write the question for the next one underneath the original problem. So f of x equals 3 minus 2x. F of 4 is what I want to find. So what happened? We've replaced x with 4. So what am I going to do on the right side of the equation? I'm going to replace x with 4. Once again, order of operations here matters. I have to do the multiplication first. So negative 2 times 4 is negative 8, and 3 minus 8 is negative 5. The last one is when you have a fraction. Do the same exact thing. We just have to be careful with simplifying. So I want to find f of 7. So what do I notice? X has been replaced with 7. So on the right side, I'm going to replace x with 7. I'm still going to put parentheses, even though here, if you don't put the parentheses, you get the same answer. Because until you are a Jedi Master like me, you do not know when that is. So just always do it. Alright, 7 minus 2 is 5 over 5, and 5 divided by 5 is 1.